Kia ora, year 12 and 13. This is the first part of question 2 of the 2015 complex numbers paper. So in here we've got 2 achieved questions and a merit question. As usual, have a go at them before I go through them. Okay, first question. What is the remainder when 2x cubed plus x squared, this thing here, is divided by x plus 3? So the easiest way to do that is to, well, 2 ways to do it, but we can use the remainder theorem, and we can say that if we substitute in x equals -3, and we see what we get out, and that's going to be my remainder. So 2 times -3 cubed plus -3 squared minus 5 times -3 plus 7 will give me the leftover. So that's -54 plus 9 plus 15 plus 7. And that equals, well, you're going to grab your calculator and do that. I'm going to try and do it in my head. -54 plus 31 is equal to -23. Okay, so that's using the remainder theorem. The other way to do it, of course, is just to get on with it and do your long division, but that's going to take a bit longer. So x plus 3 into 2x cubed plus x squared minus 5x plus 7. Right? And so we can work that through, and we'd go like this: 2x squared, and so on. Alright, but we don't need to do that because the remainder theorem tells me that all I need to do is to say, let's solve that little equation, x plus 3 equals 0. So we'll evaluate the expression when x is equal to -3. Right, so remember the factor theorem says that if x plus 3 is a factor, then when I substitute in x equals -3, this will work out to be 0. Okay, that's me getting off topic, sorry about that. Okay, on to part B. So we've got this complex number, 2 plus 3i over 5 plus I, and it can be expressed in this form here. So we need to work that out. So whenever we see a complex number as the denominator, we know we're going to multiply by the conjugate over the conjugate like that. Okay, pop your invisible brackets in, and off we go. So in the denominator we get 25 plus 5i minus 5i minus I squared, so that's going to be plus 1. Right, numerator 10 plus 15i minus 2i minus 3i squared, which is plus 3. So that gives me 13 over 26 plus 13i over 26, which equals 0.5 times 1 plus I. So k is equal to 0.5. Okay, another achieved question. Alright, we're asked to find real numbers a, b and c such that this expression is true. So on this side I've got a fraction, algebraic fraction with one term. Over here I've got 3 terms split out. So we're going to add these together and get a common denominator. So we have 1 over x squared times x minus 1. Common denominator is going to be x squared times x minus 1. So note that they match, which is going to help me a lot. So what do I have to do to a to have this common denominator? Well, I have to go a times x minus 1 plus b, well it's already b over x squared, so it's going to be b times x, oh sorry, something going funny with the app, b times x minus 1 plus c times x squared. Right, so now I can just equate the two numerators, and we get 1 is equal to ax squared minus ax plus bx minus b plus cx squared. Now we're going to sort that out and write that as a plus c x squared plus b minus a x minus b. So that means I know that 1 has to equal -b. Right? So I'm matching up coefficients, and I know that there have to be no x squared, so a plus c must be 0, and b minus a must also equal 0. So if 1 equals negative b, b equals negative 1, so a must equal positive 1 in here, and c must equal negative 1. Alright, so that's again the idea of matching up coefficients that's come up earlier in question 1 of last year's paper. So it's quite an important idea in algebra. Thanks for watching. I'll be back with parts D and E soon.